Effect of catalysts. See, the catalysts are the chemical substances which alters the rate of the reaction without getting actually permanently chemically changed. It can be put up like this. These are the chemical substances which increases the rate of the reaction without getting consumed in the reaction. So practically no chemical composition of the reactant gets changed. It remains as such and it can be recovered back. Now this phenomenon is called, or the phenomenon by which increases the rate of the reaction is called catalysis. So catalysis is the increasing the rate of the reaction by use of a chemical called catalyst. Now they are very important because and very significant in the chemical kinetics, because after understanding the factors and the effects of the rate of the reaction, what all are the factors which affects the rate of any particular reaction, we always are in thought that why not to have certain chemicals which can increase the rate of the reaction, which are usually slower, or which can decrease the rate of the reaction, which are actually faster. So therefore we know the enzymes which are actually the biocatalysts, which are the ones which catalyzes our biochemical reactions to a great extent, and without which we are not able to actually get our physiological mechanism completed in our body. What we have to understand is that these catalysts basically are also widely used in the normal reactions, and they play a very important role in increasing the rate of the reaction. Now remember, the most important thing, we have to understand how a catalyst increases the rate of the reaction. Now, the Arrhenius equation gave the answer to this. And actually, what they do is, it can be explained from here, from the potential energy graph, that once this potential energy of the reactants and the products is plotted with reaction coordinates, what we find is that if suppose this is the reactant we have and this is the product they were forming, and the reaction was following this usual path, and it was the activation energy in the absence of, here I am writing down, this EA is activation energy when catalyst is absent. So when you do the same reaction in presence of catalyst, the catalyst lowers the activation energy of the reaction by providing an alternate path to the reaction. So remember, it doesn't decreases the threshold energy, it doesn't increases the rate of the reaction, it doesn't affect the equilibrium constant. What it does is, it reduces the time taken to achieve the equilibrium, to reach the state of the equilibrium. It reduces the EA. How it reduces? By providing an alternate path, by providing an activated complex method. It combines with the reactants, forms temporary bonds, forms an activated complex, which further decomposes to give you the catalyst and the product back. So when we use the catalyst, what happens is the reaction follows this path. So the activation energy required now becomes EP. So what is your EP? Is when catalyst is present. So now you can see this. This is the alternate path which is being provided by the catalyst. Otherwise, the reaction was supposed to go to this ET and then to reach to this for product. But when we use as a catalyst, this is with catalyst, what we find is that this reaction is following a separate alternate path. EA required becomes less than the one which was used when there was no catalyst, and therefore the rate of the reaction gets increased.